So now we have another company, a competing company thinks C and CO are a big problem. Okay, so they don't like C and CO as much. So they decide to use excess oxygen in their engine to alleviate this. So they decide, if I need 1 gram of oxygen, I'm going to put 5 grams of oxygen instead, because oxygen is a lot of it in the air. I better use it to avoid these guys. So are there any problems with this? Okay. Is there any problem with just using heaps and heaps of oxygen? Well, yes. I wouldn't ask this if there wasn't. So while using excess oxygen will certainly reduce CO and C easily, the extra O2 will allow complete combustion, which will generate a large amount of heat. Okay? So complete combustion produces a lot of heat. Now that creates more NOx. So again, we've got that same problem. So NOx is one problem, but additionally, by using excess oxygen, the extra gas that's not used up will actually absorb some of the heat from the combustion, and it will act as a parasitic loss. Okay? So because it's absorbing some of that heat, the gas itself, well then some of that heat that it's absorbed won't get to wherever you want it to go, which means that you've wasted it. So it's less than the total energy available. So you've wasted that heat. So again, that's a problem. You've wasted heat, energy that you could have used, and also you're producing more NOx. So this company sort of not quite come to terms, haven't quite dealt with everything that they should have. So you can see that there's a problem still. And again, that's that balancing act all over again. Still a problem. So we'll move on to question 10. So catalytic converters are used to reduce NOx in petrol cars. However, they aren't used in diesel cars. What is the reason behind this? Okay, so that's quite a complicated question for you because you've just started learning this. But this is about learning new things. So hopefully you can go and look at your car and say, well, I know now what's going on. So why isn't it used? Well, in a diesel car, the exhaust gas has a really high concentration of oxygen in it. Now, that sounds weird, but by the way that the diesel engine works is that there's a lot of oxygen in the cylinder and not much fuel. It's just the timing of the fuel being injected that produces all this CO and C. But it still has a lot of oxygen in it. Now, this oxygen quickly reacts with whatever chemical you tried to use to remove the NOx. Because there's a lot of oxygen there, and also it's very reactive because it's hot, and oxygen is quite a reactive gas. So when it gets to that catalyst, it's going to react with it before this NOx can. So you know, what's the point? So with such a high concentration, the likelihood of reducing the NOx is reducing as in chemically reducing, not like reducing as in total amount. Of reducing, the NOx is severely reduced because the NOx simply just can't get to the catalyst because there's so much oxygen in the way. And that's why. Okay? So for those who want to study engines more, you can look at all of these things. We looked at how combustion sort of affects, what kind of things affect the pollutant formation of combustion, particularly in cars. So we looked at C, CO, CO2, NOx, SOx. And so hopefully you've learned about what are the implications of actually using these combustion systems in our everyday life. So I look forward to seeing you at our next lesson.